Hello, this is the last homework problem of homework 7. So now the bars of the truss each have a cross section of 1.75 inch square. The maximum average normal stress in any bar is not to exceed sigma 23 ksi. Determine the maximum magnitude of the loads that can be applied of the truss. So in joint B we have a load of P, joint A we have a load of 0.5 P. Now I'll start with drawing my reactions, dy, dx. Here will be ey, and then we find ey, and then we find that ex is 0 later on. So first, I will start doing my moment around d equals 0. Counterclockwise is positive. So I know 3 times ey is giving me a counterclockwise moment minus 4p minus 8 times 0.5p equals 0. So I have 3 ey is equal 8p. So my ey is equal 8p over 3. So now I can find my by sum of forces in y direction equals 0. I know that dy plus ey equals 0. So my dy is equal minus 8p over 3. Now let's starting to find our members and annotate our values. So I'll start with joint E just to find our member force EC. So here I have EY, here I have CE, my force CE. Here I have EX, and if I do the sum of forces in X equals 0, so I have EX equals 0. If I do the sum of the forces in y direction equals 0, I have EY plus FCE equals 0. So I have my force CE is minus 8p over 3. So in the last slide I'll copy every member force we found to find our maximum load P. So here is in compression. Since the question is not making the differentiation between compression and tension, we're gonna use the same value. Now we have this joint, this member force. Now I'm gonna start with A. Why? Because I think it's easier. So starting with A, I have joint A. Here I have 0.5p. Here I have our force AB. And here, an angle, I have a force AC. So I know here is 3 and here is 5. So our angle is our angle 3, 4, 5. So I know if I decompose my forces, I have the force here is FAC times 3 over 5, and our force down FAC times 4 over 5. Now I can use my strategy. Sum of the forces in X direction equals 0. So I know 0.5p plus 3 FAC over 5 equals 0. So I know my FAC is equal minus 2.5p over 3. So I have this one, and now I discovered this one. Now, if I do my sum of forces in y direction equals 0, I'll have FAB plus FAC times 4 over 5 equals 0. So my FAB equals minus FAC is minus 2.5 P over 3 times 4 over 5. So I discover my FAB here. FAB is equal to P over 3. So now I discover this one. Now we can go to joint B. So joint B. My joint B I have here, that is our FAB that we just discovered. Here is our P load. Here is our FBC. And here we have our FBD. So if I do the sum of forces in x direction equals 0, I'll have FBC plus P equals 0. So I have my FBC equals minus P, that will be in compression. If I use the sum of forces in y direction, I'll have FAB minus FBD equals 0. So I have our FAB is equal to P over 3. That's the same as our FBD. So now I discover this one and this one. To find the other member, I use joint C. So joint C, I have here going 45 degrees our FAC. Here we have our FBC. Here we have our FCE that we discovered, and then here with another 45 degree angle we have our FDC. So the same way we did for FAC, we know here is FDC times 3 over 5, and here is our FAC times 3 over 5. So if I do the sum of forces in in X equals 0, I'll have FBC plus FAC times 3 over 5 plus FDC times 3 over 5 has to be 0. So I have FBC plus FAC times 3 over 5 is equal minus FDC times 3 over 5. Our FBC is minus P. Our FAC is minus 2.5 P over 3 times 3 over 5. That everything multiplies 5 over 3 equals minus FDC. So here I have minus 5P over 3 minus 2.5 P over 3 is equal minus FDC. So I discovered that my FDC is equal 7.5 P over 3. So now I have the list of members. So FAC is minus 2.5 P over 3. FAB is equal to P over 3. FBC is equal minus P. FBD is 2P over 3. FCE is minus 8P over 3. And our FDC is equal 7.5P over 3. So we have to discover our ultimate shear stress is equal to our force, that I'll put N, over area. So we have to discover what's our maximum force that can be applied. So I use normal stress times area is our normal force. Which normal force I have to use? I have to use the biggest one because I want to find my maximum load that I can use. So I know that is 23 KSI times 1.75 inches square is equal 8P over 3. I didn't put minus just to find our load, the magnitude. So here we have the units. We have KSI in square. So our unit of P will be in KIP. So I have my P is equal 23 times 1.75 times 3 divided by 8. So our P max is equal 15.1 KIP. So this is the last problem for the homework 7.